You're made of stardust as well. Different color. Killer shirt, right? Liquid blue. Cap piece. TV designed their own caps. Alright, so I read this amazing article. It's called The Genesis Project. Should we gift the cosmos with life? The search for what we would deem to be habitable worlds orbiting other stars has reached a crossroads in recent years. As our technology and techniques improve, we've been able to identify small rocky worlds orbiting within other stars' habitable zones. So far, we can measure an exoplanet's mass, understand its physical size, even calculate its average density, revealing whether or not the planet may contain quantities of water, for example. Add these factors to our knowledge of that alien world's orbit, and we are given tantalizing clues as to whether liquid water may persist on its surface. These apparently habitable worlds are quickly labeled Earth-like, but they might not be like Earth at all. There's a lot more to our planet besides its mass and orbit that makes it habitable, namely our thick atmosphere and protective magnetic sphere, both of which safeguarded burgeoning terrestrial life around 4 billion years ago from the ravages of space weather. Lacking sufficiently powerful observatories, we're not able to detect atmospheres, let alone magnetospheres, around distant small exoplanets, so the Earth-like moniker is premature at best. But as we continue to discover all the weird, wonderful, and extremely rare exoplanets our galaxy has on offer, we're finding the potential for worlds that may be considered habitable for short periods, hypothetically allowing life as we know it to be sparked only for the habitable conditions in these worlds' atmospheres to dramatically change, snuffing out the immature life forms. An often overlooked factor in the science behind the evolution of life is time, and many of the exoplanets we found may well be habitable during short periods of their existence, but not long enough to allow life to gain a foothold. Claudius Gross from the Institute of Theoretical Physics at Goethe University Frankfurt investigates the possibility of giving life a helping hand by blasting it into interstellar space and flinging our ready-made biology toward exoplanets that may only have a very short window of habitability. It is therefore certain that we will discover a large number of exoplanets which are inhabitable intermittently but not permanently, Gross said in a statement. Life would indeed be possible on these planets, but it would not have the time to grow and develop independently. When basic life took hold on Earth, its very existence helped to shape the habitability of our atmosphere. For example, bacterial mats changed the chemistry of atmospheric gases, boosting its oxygen content and facilitating the evolution of complex eukaryotic cells upon which all multicellular life is based. In Gross's discussion, he imagines sending a small interstellar probe to another star system. On arrival, that probe would somehow slow down, and using an onboard biological laboratory would synthesize a selection of single-celled organisms that would then be dropped into a habitable yet lifeless world. Should this biological arc of sorts see the first microbial life, potentially billions of years of evolution would have been skipped on that world, allowing life to take hold within the tight window of opportunity, possibly allowing it to spawn a self-sustaining alien ecosystem with a very terrestrial flavor. In this way, we could jump to approximately 4 billion years, which have been necessary on Earth to reach the Perkamian stage of development, out of which the animal world developed about 500 million years ago, he added. This highly speculative method of seeding life is called, perhaps unsurprisingly, the Genesis Project. And Gross sees it as a mean for us to give life something back. Seeding life on other worlds is not a new concept. Science fiction has tackled it countless times, and there are some scientific foundations for that idea. The mechanism known as panspermia is a hypothesis that governs the transfer of life from one planet to another. Should a massive asteroid hit one planet brimming with life, sending a chunk of rock packed with living microbes into space, that rock may land on another planet with some habitable qualities, allowing a few of the surviving microbes that hitch a ride on the rock to make a new home. I hear people saying, "Oh my gosh." But the mechanism described by Gross is a variation on the directed panspermia hypothesis, where an intelligent civilization wants to send life on other worlds in their image, sending biological capsules to spark the burn of life elsewhere. However, we quickly fall into an ethical trap. Just because we have life on Earth, is it our biological obligation to share with the rest of the galaxy? Or would such an act be no better than biological pollution, or even worse, a biological weapon? Just because we've got it doesn't mean the rest of the universe wants it. One obvious problem is the question of native life forms. Say if a target world already has a rapidly evolving life form that's taken the opportunity to gain a foothold in that world, a Genesis Project capsule dropping on their heads filled with an out-of-the-box Earth brand goo would be disastrous. Though Gross points out that great pains should be taken to ensure the target planet isn't already inhabited, when talking about the potential genocide of the foundational biology of a future alien race, it would be hard to justify such a risky mission. Pretty cool. That's pretty futuristic. Yeah. Alright, folks. Welcome to the future.